So today we are talking about outliers. So you may notice a value in a data set that looks suspiciously different from all of the other values. In statistics, that might be an outlier, which is an extreme data value that is so distinctly different from all of the other points that it distorts your numeric summaries. Now, the whole point of numerically summarizing the data is so that you have an accurate representation to help people digest the information that you've collected. And so if you distort those numeric summaries, it's no longer an accurate representation of whatever you're working with. So it's a good idea to figure out, hey, is a point an outlier? Is a value just too different? Is it messing us up? So I do want to go back to the work from yesterday. I haven't graded it all. But looking at these four people and their test grades, this was question number 5 on your practice from yesterday. Do you notice anything kind of weird about maybe one of these box plots? You said D? Yeah, D has a whisker that is so long you could land a plane on it, right? It looks just so different from all of the others. And if you look at it, Jorge had an average of about 43 with a standard deviation of 8.5, and that was the lowest standard deviation anywhere on this paper. Meaning Jorge was very consistent with his test scores. Now, in all fairness, he was consistently pretty bad, right? And that's why his box plot is all the way over here in the 40s and 50s range. The next lowest standard deviation was Rosie, who had an 8.9, pretty close, but her average was way, way higher at 88.3. And you can see that her box plot is moved further to the right, saying her scores tend to be a little bit higher. Ada, her average was a 72.5 with a standard deviation of 12. So you can see that 12 made her box and whisker plot a little bit wider than these two. The larger your standard deviation, the wider your box plot is going to be. But also, she was pretty consistent with the 60s. She had 1, 2, 3 60s. There were so many of them that it actually cut off one of the whiskers of her box plot. That can happen whenever one end of your data set's pretty consistent. And then we got Jose, whose average is 78 with a standard deviation of 35.78. Okay, that massive standard deviation is why his box and whisker plot is so long, right? And that whisker being extremely long, if you look at all of his other grades, 100, 80, 90, 100, 100, he actually, other than that 0, has some of the best grades on all of these tests. I mean, if you compare, he's tied for the best grade, got the best grade, almost the best grade, pretty close, tied for the best grade, has the best grade. This one, I don't know what happened. Maybe he didn't take it, maybe he wasn't there that day, but it just tanked his average. So the question is the 78 average a fair representation of Jose's abilities in that class? Probably not. If you look, his box plot is even further to the right than Rosie's. The actual box part is further to the right. It even borders the 100 because he's gotten so many 100s. So that's kind of going to be the basis of what we're talking about today, is how do you know if some data is fair? To figure that out, the first thing you need to do is find something called the interquartile range, which we abbreviate IQR. Let's keep on filling in some of these blanks. The IQR is another measure of spread. We talked about measures of spread on Tuesday with the range and the standard deviation. The IQR, the interquartile range, is another measure of spread. And it just measures the middle 50% of the data. So everybody from the 25 percentile up to the 75 percentile. And it's just found by subtracting Q3 minus Q1. Super easy to find. Once we've got the IQR, we're going to use that to establish what we call fences. Each of these fences is going to represent a limit for what is an acceptable data point. Anything that's beyond those limits is going to be considered an outlier. And the formulas are right here. For the lower fence, you start at the first quartile and you subtract 1.5 times the IQR. Anything lower than this number is going to be an outlier. For the upper fence, start at Q3 and add 1.5 times the IQR. Anything above that number is also going to be considered an outlier. So let's look at a set of data that's pretty cut and dry about, there's probably an outlier here. The table below shows the salary in thousands of dollars of a random sample of 16 employees at a company. Do you notice anything weird about maybe one of those salaries? Yeah. So a lot of these people are making somewhere in the 20s and 30s, and then there's just Miss Jackson who's making $100,000. That feels a little out of place considering all the other numbers around it. So what we're going to do is see if that's an outlier, and a really important piece for today is to see how the outlier affects this data. So the first thing I'm going to do is just get the measures of center, get those descriptive statistics. So grab your calculator. And then a good first step is to reset your calculator. How do we do that? Fabulous. Second plus 712. Again, second plus 712. It'll take you to that RAM cleared screen, and then stat edit. Stat, go into that edit, and then type in all these numbers. You do not have to type in the 1,000. Just type in 28, 24, 36, 30. That'll make it quicker to type. We're typing all 16 of these numbers in the same column. Bless you. And I'm just going to double check that I didn't make any typos. 30, 34, 40, 24. Okay. So, I'm going to go to Stat, go over to the Calc menu, and select that first option, and pull up my one variable stats. Everybody here with the 34.375 as your first number? Cool. So, looking at this screen, I can pull in a lot of these numbers. That first number, 34.375, that's our mean. I'm going to round that off to 34.4. To get the median, I'm going to scroll down. The median is 30. Skipping down a little bit, the 5-number summary, that's the same median. 30 is 30 here. And because I scrolled down to get the median for my calculator, I've got the 5-number summary here. The minimum is 20, Q1 is 25, Q3 is 35, and the max is 100. Okay, well now that I know that the min is 20 and the max is 100, the range is pretty easy to find. 100 minus 20. The interquartile range, the IQR, is also pretty easy to find. Q3 minus Q1. 35 minus 25 is 10. For this one, the IQR, I took Q3 and subtracted Q1. The standard deviation is also on my calculator. I had scrolled past it. But that little sigma x, 17.8356, blah, 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 I'm going to round that off to 17.8. The only one that the calculator does not feel like is important enough to tell you is the mode. It's just the number that repeats most often. Any guesses? 30. Okay, before I worry about any outliers, I want to go ahead and draw this box and whisker plot. So we're going to be plotting this 5-number summary. This is what we talked about yesterday. To draw a box and whisker plot, start with putting a point above each of these numbers. So a dot above 20, a dot above 25, a dot above 30, a dot above 35, and a dot all the way over here above 100. Then, those middle 3 dots, the 25, 30, and 35, you're going to draw a little vertical line through them. And then connect the bottom and top of those lines to get your box. For the whiskers, connect the minimum to the Q1 and the maximum in Q3. This long, long, long line. So this is kind of confirming our suspicion that maybe Miss Jackson's salary of $100,000 might be an outlier. Because again, we got one of those super long whiskers. So here's how we check and see if something's an outlier. The first thing we're going to do is use those 2 fence formulas. And to use those, or get those fence formulas, the numbers I'm going to use are the Q1 in the IQR and the Q3 in the IQR. So, for the lower fence, Q1 is 25. Subtract 1.5 times the IQR, which is 10. Again, I'm just using this formula right here. But I plugged in 25 for Q1 and 10 for the IQR. And then just throw that in your calculator. What do you get? 10. What that means is any salary below $10,000 is going to be considered an outlier based on what we've got from this company. Do we have any outliers on the low end? No, no one's making less than 10 grand, so that's fine. Then, for the upper fence, Q3 plus 1.5 times the IQR. So Q3 is 35 plus 1.5 times the IQR, which is still 10. Add that, I think you get 50. Okay, do we have any outliers on the high end? The rule is anyone who makes more than $50,000 is considered an outlier. Yeah, Ms. Jackson is an outlier. So what we're going to do is cross out this $100,000. We're going to toss it from our data because it statistically is messing up our data, specifically these numeric summaries. And then I'm going to go back to my calculator, back to stat edit, and find that 100. And when I get to it, hit the delete button. And now I've only got 15 numbers typed in instead of 16. That's fine. We're going to go back to stat, calc, and look at those one variable stats again. There's two really important changes I want to focus on. Those two really important changes are the mean and the standard deviation. The mean used to be an average of around $34.4 thousand a year. Well, now deleting that 100 chopped it down to just 30. I'm going to cross it out and write 30. And then if I look down here at the standard deviation, it's 5.8. I'm going to cross out 17.8 and write 5.8. Now, if you look at the rest of these numbers, the median did not change. The Q1 and Q3 went down just one step. That's fine. It also says the max is 40. Okay? Well, because we tossed out that 100, if we're going to draw a box and whisker plot with that 100 as an outlier, we're going to toss it out and just use the next highest number. So the next highest salary in this list is 40,000. So, by tossing out that outlier, we saw that the average went down to exactly what the median and the mode were. Well, the fact that these three numbers, these three measures of center are the same, tells me that, yeah, whenever you apply to this company, the average salary is going to be around $30,000. Give or take, that give or take is now a lot cleaner. Give or take 5.8, that says you can be very confident that your salary is going to be close to $30,000 versus not very confident that your salary is going to be close to $30,000. Okay? Last thing is we got to draw a new box and whisker plot. So we tossed out any values outside those ranges and recalculated the mean and the standard deviation. Now we're going to draw a modified box plot. All that means is use the 20, 25, 30, 35, and 40. Let's go ahead and plot those points again. 20, 25, 30, 35, and 40. Okay, that definitely shrunk our box and whisker plot a lot. The more narrow it is, the better your data is at representing whatever you're trying to represent. And the fact that each of these pieces is the same width is even better. The only other thing is, if you have any outliers, you're going to plot the outliers well with an X. So because we had a 100 as an outlier over here, I'm going to write an X above the 100. This part is not required, but a lot of people do it anyway. If you have an outlier, sometimes they'll say what the fence is. The upper fence was 50, and so you'll see like a dotted line through here saying, hey, that's the limit for whatever. By the way, the rule for an outlier is anything beyond that number. So like 55 would be an outlier, 51 would be an outlier, but 50 would not be. Okay? If it's on that fence, not an outlier. Sound okay? Okay, let's do another one together. Someone in my first period loves to call me Mr. Carterberry. I don't know why. So Mr. Carterberry asked his students to keep track of how many notifications they received on their phone during the class. They just left it face up on their desk. Anytime it lit up, they just put a little tally mark on a sticky note they had, and these are the results. I actually did this a few years ago with one of my upper level classes whenever we were talking about stats and probability. These are not the actual numbers though. So we've got Aiden got 23 notifications, Becky got 27. Scrolling through, ooh, wow, Joe got 90. John got 60, and poor Ophelia didn't get any. Poor Ophelia, nobody likes her. Sam, oh yeah, Sam got 30. It's a nice number. So what I want to do is calculate those descriptive statistics. So I've already got all this other data typed in. Let's clear it out. Second plus 712. And then carefully type in these numbers. Okay, I'm going to go ahead and pull up those descriptive statistics. So stat, calc, one variable stats. Let's start plugging in some of these numbers. The average number of texts received were 29. I see the standard deviation is 17.9. Scrolling down for the 5-number summary, I get 0, 20, 25, 30, and 90. Now, since I put that 25 as the MED, the median for the 5-number summary, that's the same thing up here. What is the range? 90. And you find that by just saying the max minus the min, 90 minus 0. What is the IQR? 10. You find that by saying Q3 minus Q1, 30 minus 20. The only number that is not listed is the mode. I'll just go and tell you, it's 20. Any questions about how I got any of these numbers so far, y'all? I'm going to take your dead silence as we love finding outliers. So let's do that. The lower fence, Q1 minus 1.5 times the IQR. Q1 is 20 minus 1.5 times 10. Okay, that is Q1 minus 1.5 times the IQR. And that comes out to 5. The upper fence is Q3 plus 1.5 times the IQR. Which comes out to 45. Do we have any outliers in this data set? Yeah, what are they? Definitely Joe with his 90 texts. Any others? How do I figure out that 90 is an outlier? Okay, these two numbers that we just found. Are there any numbers below 5? Yeah, Ophelia. Poor Ophelia with her 0 texts. She's actually considered statistically weird. And then are there any numbers above 45? Well, yeah, the 90 and also John and the 60. Maybe Joe and John are part of like some crazy group chat or something. I don't know. Okay. Now, part C says recalculate, cross out, and rewrite the mean and standard deviation without the outliers. So, that means go back to stat edit, find that 90, 60, and 0, and delete all 3 of them. Delete the 90, delete the 60, delete the 0. All you got to do is hit the DEL, delete button. And I know a lot of these numbers change, but the ones we're really most concerned about are how the mean changes, how the standard deviation changes, and then you're probably going to have to change your min and your max since there's outliers on both ends. The new mean is 25.3. The new standard deviation is about 6.2. Scrolling down, the new minimum is 15, and the new maximum is 40. By the way, while we're down here looking at the min and the max, the median changed as well. It changed from 25 to 24. But if you compare the mean and the median changed a little bit more than the median. The mean went down by almost 4. The median just went down 1. Also, we'd love to see a small standard deviation. Going from about 18 to about 6, that's good. Part D, I know on the front we drew both box plots. We're just going to draw the modified one after we cut out these outliers. So, plot a point above 15, and above 20, above 25, above 30, and above 40. your 3 vertical bars there. And connect your whiskers. Don't forget, if you had outliers, you should plot them with a little X. So X above the 0, above the 60, and above the 90. And then also I'm going to draw those little dotted fences. Can I get a scale of 1 to 5 on how we're feeling about this? Now, we'll be fair, it is quite a bit of work, right? But I hope it's not feeling like it's hard work. Example 3, I'm going to get you started on it, but let you work on it. We've got a frequency table here, so you got to be really careful how you type in these numbers. I'm going to go ahead and reset my calculator. If it says times 6 minutes, students 2, times 7 minutes, students 6, what I'm going to type in is 6, 6, 7, 7, 7, 7, 7, 7, 8, 8, 8, 8, 8, 9, 9, 9, 10, 10, 10. Type the top number as many times as the bottom number says to. What we're working with is how many minutes to the nearest minute each person on this cross-country team ran a mile. Whenever you get to the 12, 13, 14, all of those that have a 0, don't type them. We didn't have anybody who ran around 12 minutes or 13 minutes and so on.
Is it 24 then?
Do what?
Is it 24 then?
There are 24 numbers, yes. Here are those descriptive statistics. The mode, don't overthink it. If the bottom number is the highest at 6, there were 6 students who ran the mile in 7 minutes, that's going to be your mode. On a frequency table, you just look for the highest count down here. But you keep working to find those fences and draw the modified box plot. Make sure you also look for the new mean and standard deviation. Okay, here are those fences. You get 2.5 and 14.5. We didn't have anybody who ran the mile faster than 2.5 minutes, which is good because that's inhumanly fast. We did have some people who ran it slower than 14.5 minutes. Honestly, I'm right there with you, but you're on the cross-country team, so maybe you should be running a little bit faster than that. Draw the modified box plot. Got some practice for you. I'll turn you loose here in just a second, but I do want to get you started. Okay, on the front, you just got one set of data. It's a dot plot. So remember to type these in. You're going to type in 0, 2, 2, 3, 5, 5, 5, 6, 6, 6, 6, 7, 7, 8, 9, 9, 10, 10, 15, 20. answer the questions just like we have been. Don't forget to recalculate the mean and the standard deviation. I want to see how those change. And then I got one opinion question. Again, these are opinion questions, but you have to have a valid opinion based on what you're seeing. Question is, whenever Hannah filled out the job application, it mentioned an average of a $7 tip. Based on what you find, including the outliers and how it affects it, is that a truthful statement? Why or why not? Then on the back, you're going to be comparing two sets of data. I would highly recommend you work with a partner. One of you do the morning classes numbers, and one of you do the afternoon classes numbers. Okay? I don't have all of the descriptive statistics here. I've just got the mean, standard deviation, the 5-number summary, and the IQR. I want you to compare those for the two classes. Also find the lower and upper fences for the two classes. Toss out any outliers, recalculate the mean and the standard deviation. And then you're going to be plotting a double box and whisker plot. All that means is, y'all, whenever you draw these, you're just going to draw your first one, like let's say these are the numbers. By the way, don't copy this down because this is definitely not the right answer. And then you'll draw the other one just kind of hovering above it. That's all a double box and whisker plot is. It's two above each other on the same line. And then E, another opinion question. Now, this might sound familiar. There was a class competition to see which class had the highest overall average score. Which class would win this award based on this data? Now, I'm going to tell you, it's close, right? But I want to know your reasoning based on those outliers and what they did to the data. Sound okay? Okay. That's great. I said sound okay, and someone screams no from the other classroom. All right, y'all, get to work. I'm going to ask you to turn this in when you're done.